I choose one. Oh, yes. Okay, so yeah, we should start the next thing. Let's just throw you in and see how we do. Okay, how about this?
Particle is projected from a point on a horizontal plane with initial velocity. So initial velocity is 40. Angle A. A bit horizontal, and it goes something like that. Where tan A is 3/4. So if you make a triangle, so tan A is 3/4, so opposite over adjacent. So 3/4. So the hypotenuse is 5. And then find the horizontal and vertical components of the initial velocity. Is it just 4 over 3j?
The horizontal. So, projectile is horizontal plane. Velocity is 40. So that means that the ratio is like 3:4, but the absolute value is 40. So the hypotenuse is actually 40.
Okay.
So if you were to write them as a ratio, it would be like 3:4:5. And where 5 is the hypotenuse. And now they tell us the magnitude is 40. So we have our triangle sketch 3, 4, 5. And then in reality, they tell us that that's 40.
So so how do you work it out?
What do you have to do to go from 5 to 40? If these are two triangles, maybe one's an enlargement.
Times it by 8.
Yep.
Okay. So you times this by 8 as well?
Mm-hmm.
So 40, 32 and 24.
So that is 32 and 24. And what is 24 over 32? What does that simplify down to?
3/4.
Yeah, and so the tan of that angle is 3/4. Or maybe, sorry, I wrote the angle in the wrong place. It should be up there. Okay. And so what were we asked to find? Find the horizontal and vertical components of the initial velocity. Yeah. Were we given... Okay. I think that's it, isn't it?
I don't know.
I think, well, what's the horizontal?
24.
And the vertical?
There's 2.
Seems like it's done to me. Yeah. And so, how would you express those in I and J vectors?
24i plus 32j.
24i plus 32j. So they did that. They did a bunch of stuff. Oh, 32i plus 24j. Was that my fault? Hang on. I'm going to blame you anyway. Tan is opposite over adjacent. It's because I started with the angle there. So it's just the other way around. It's opposite over adjacent.
Okay.
Okay. Opposite is 3, 4. Opposite. That would be 32 and 24. Okay. 5 plus 24j. Yeah, almighty tan. That's correct, I believe. So tan.
Why is that 32 though? If you do 3 times 8, that's 24.
So I swapped them around. 24j and 32i.
Yeah, but why?
Because tan is opposite over adjacent.
Yeah.
So tan is opposite over adjacent. So if I was to sketch a triangle, and this is the angle alpha, then the opposite is 3, the adjacent is 4.
Oh, okay.
Yeah, and so across is more than up. Oh, and there's a solution, sure. Okay, how about this? This time they give us the vector, and we have to get the stuff from it.
Is projected with velocity that where I and J are the unit vectors in the horizontal and vertical direction respectively. Find the initial speed of the particle and its angle of projection.
Mm-hmm.
So initial speed, do you like find the magnitude and then?
Sure.
So that's is that the answer?
Yeah, looks good to me. So if you think about it, 3i is like that, 5j is like that, and so the magnitude of the vector will just be the hypotenuse, so it will be Pythagoras.
Yeah. And then find the angle of projection. So that's just theta equals 5 over tan minus 1, 5 over 3.
Yep.
So tan minus 1, 5 over 3 is, I'm in radians, I'm on 59 degrees, and how many decimal places is it? 2?
Doesn't say. 59 degrees. There you go. And root 34. Okay. And then we could do those exercises. You seem like they're good for them. Let's do these. So I think you might be fine for that. Okay, let's try this.
Particles projected with the origin with velocity. Is it 5i and 8j?
Yeah, if you like.
Use v equals u equals e to one expression for the velocity of the particle. Okay, so 5.8 equals. Oh no, v equals 5.8 minus 9.8. Oh, is it 0 and minus 9.8?
That's resolving vertically, is it?
Is it horizontal or?
I will say. Let me think about this. It would have to be horizontal if it is. No, it would have to be use v equals u plus h minus velocity at time t. But they just mean the absolute velocity. Use S equals to find the expression for the displacement at time t. So they mean diagonally. Okay, but what's its acceleration?
9.8, isn't it?
No, that's its well, the magnitude of that would be its initial thing. S equals VT. Okay, what would it be if you were resolving horizontally?
U would equal 5 squared plus 8 squared. The square root of that is root 89, which is 9.43.
So that would be resolving like diagonally. That would be the absolute.
Yeah.
5 that way. So that for that one, U would be what was it? Root 89.
Yeah.
What's the horizontal component?
8. No, 5.
So that would be, and that's always S equals VT. So that would be S equals 5t. If we were resolving vertically,
S equals 8t.
U is 8. This one only works vertically. Excuse me, this one only works horizontally. S equals VT because there's no gravity. Resolving vertically, U is 8. What is A?
Equals 8. B equals, oh, A is minus 9.8.
They told us that T is T, to just do it in terms of T. And we want V. So what would that be?
8 minus 9.82.
Okay, and just in case they were asking for this one, the diagonal thing. So V equals U plus AT at time T. Okay, so so U is that. We have to find V. T is T. And I don't know A. Is A just minus 9.8?
I have no idea.
I doubt it. But okay, let's try it. What is this one?
Root 89. Oh, wait.
Yeah.
Plus minus 9.82.
Okay, I just want to check that. Because it doesn't say which direction. 5 and then 8 minus 9.8t. 5 and 8 minus... Oh, 8 minus 9.8t. So they were talking about this one. Oh, hold on. Hold the phone. I see what they're saying. So it's just a quicker... So you don't have to do the Pythagoras thing. They're saying... yes, I get it. You don't have to do the Pythagoras thing. It's just a quicker way of doing it. Okay, we'll see more of it in a second. How about B?
So is 5u then, or is that 8?
U is root 89 because they meant resolving diagonally. So this is going to look something like that. Yeah, pretty terrible triangle. So resolving that way.
Yeah, okay. So to do that.
How do you do this one?
Well, A is minus 9.8, so that part's minus 4.9 t squared.
Okay.
And the ut, is that the root 89 then?
So that's root 89 t.
But I thought U was. I don't know.
U
Because
is
the first one, U is 8.
that is okay. So the final answer for the previous one, the way they phrased it, the horizontal component is 5, and the vertical component is 8 minus 9t, and was 9.8t, and actually was it 5t? 9.8t. These are just 5. Yeah. So the horizontal component is 5, and because that's not affected by acceleration, the vertical component is 8 minus 9.8t, because that is affected by gravity.
Okay.
And so when it's given to you as a vector, you can treat the two separately. So you don't have to do Pythagoras. Okay, so this one.
Do you have to use Pythagoras or?
Well, we already did, so we can use that.
So then that's the answer.
I think that's it. They might have written it as a vector. They said S is 5t and 8t minus 4.9t squared. 5t and 8 minus 9.8t squared. And I believe if you were to sub in a value for t, you would get the same answer. So they're just treating it separately. So this one is, yeah, so they're not even, it's like they would leave Pythagoras until the very end if they needed to. 8t. So if you had to find out where it was, this would give it to you as a vector, and then you would just use it, you would use Pythagoras to get the full magnitude of this once you sub in t. Let's see, so 5t after at time t, so that's 5 times t, and then 8t minus 9.8t squared. Yeah. Any questions about that?
No.
So if you subbed in the value for t, your way would have worked as well. That one. Okay. Okay, let's try this any way you like. And there are many different ways of doing these.
These equations can be used to solve problems involving projectiles. Consider a particle projected from point origin with initial velocity 15 at an angle of 30. The diagram shows the parabolic path of the projectile. The range of the projectile is the horizontal distance travelled by the projectile from origin to A. The time of flight of the projectile is time taken to travel from O to A. The time that the projectile is in the air. The time that the projectile is in the air. At points origin A, y equals 0. Okay. Write down the horizontal and vertical components of the initial velocity. So 15 cos 30 and 15 sine 30.
Correct. What is cos 30?
Root 3? I don't know. Root 3 over 2.
And so times 15?
Sticky one. Hang on. 15 root 3 over 2.
Yeah. And the other one?
Half times 15, which is 15 over 2.
Yeah, 7.5, whatever you like. And might make it easier for the later parts. Okay, B.
Use this question to find the time of flight of the projectile. is displacement. So S equals. Is it S equals ut plus half at squared?
Could be. Let's see. So, I think it's just to help you with part C. So how would you use your equation to find the time of flight for the projectile?
I need my booklet. I can't remember. Projectiles. We need to find the time of flight. Flight is. So 15 sine 30 t.
So which equation are you using?
The ut minus half at squared one. So 15 sine 30 t minus 4.9 t squared equals 0. So t can either equal 0 or t can equal calculator. What was it? 15 sine 30. Yeah, so.
And that's 7.5.
Yeah, so minus 4.9, 7.5, 1.53.
1.53. That's for C. 1.53 is correct. Okay. D.
Write an equation for the horizontal distance travelled by the particle at time t. The horizontal distance. Is that not what I just did? That's vertical, isn't it?
And you also just got time.
Write travelled by the particle at time t. For horizontal distance.
Mm-hmm.
The horizontal distance for. Wait, is it just. Oh, I didn't write it down. 15 cos 30 times 2.
Yep.
And then by substituting the value of time of flight into the equation found in part D, find the range of the projectile. So. $19.88, so 19.9. I don't know how to round it.
19.9. There you go. Any questions there?
No.
So I think you've got the main stuff there. Okay. This time we want the maximum height.
It's the same question.
It looks similar. So that's 15, that's 30. Yep. Maximum height.
I think it's the same question. Write an equation for the y component of the velocity of the particle at time t. I've just done that. Isn't that just the 15 sine 30 t minus 4.9 t squared. Oh right, we're in equation of the velocity. Yeah, isn't that what we just did?
Sure. The important thing is part B, to find the maximum height.
Use the equation to find the time when the particle is at maximum height. So you can do that by making 15 sine 30 minus 9.8 t equal to 0. Or you could have the time of flight and do it that way.
Pick one.
It's symmetrical, so let's go with half the time of flight.
Okay.
Which one's easier?
Listen to your heart.
Because in C they say how does the time relate to the time of flight of the particle.
So what was the time? 1.53? Okay.
So 1.53 divided by 2 is 0.765.
I mean, you've got everything you need there.
Which gives you
No.
that doesn't make sense.
Did you get something? Did you get something close to 0?
Yeah.
Yeah, of course you
Do you
did.
put that half time of flight into that equation?
Well, you did V equals U plus AT, and we just confirmed our answer. We're trying to find S.
The vertical.
Yeah.
What was the question? Find the maximum height.
Mm-hmm.
So 4 sine 35 t no, not 4 sine 35, that's the example here, lol. 15 sine 30 minus 4.9 t squared. Do you make that equal to 0?
What equation are you using?
I don't know, because it hasn't got s in it.
So pick one with S in it.
I can't see one with s in it, there's no letters, hang on.
There's millions of them.
S equals ut plus half at squared.
I love that equation. There you go.
So if u is 15 sine 30, yeah?
Yep.
You need to give me like a confirmation, otherwise I just get nervous.
So
Minus 4.9 t squared.
what is T?
Depends. Are we doing 1.53
You tell me.
divided by 2,
Yes.
which was 0.765?
Yeah.
So 15 sine 30 times 0.765 minus 4.9 0.7, was it 0.765? Yeah, squared gives us 2.8 or 2.9. I mean, it depends how much you want to round it to, like 2.87.
2.87 meters sounds fine.
It's not that 2.9, isn't it? It's not.
Oh, so sorry. There it is. 2.87. We actually.
That's the wrong answer.
They said find the time at the maximum height, and that was 0.765.
Lol.
Yeah. So the important bit was the height. Okay. What horizontal distance has the particle traveled when it's at its maximum height? What distance has it traveled at its maximum height?
Is that this question?
I suppose just in general, or if you like specifically this question, yeah.
What horizontal distance has it travelled? I don't get it.
What is the range?
0 to whatever its maximum height was.
No.
Oh, range. This range.
Yeah.
This range here on the horizontal. 0 to 1.53.
That's not the answer we got for part D of C2. You said it was 19.88 or 19.9?
Did we? Oh yeah, it's 19.88.
So that's the kind of distance it travelled. At its maximum height, what do you know about the distance it travelled?
19.88. 9.94
Yep.
meters.
So it's half of its total thing. And what is the direction of the velocity when the projectile is at its maximum height? The direction of the velocity when it's at its maximum height.
30 degrees. I don't know. Above ground.
Well, when it comes back down, it's going to come down at 30. Is it 0? When the projectile has maximum height, the vertical component of the velocity is 0. Oh, sorry, the vertical component. They really need to say the vertical.
I don't really like these questions, I'm not gonna lie. And I really hope they never come up.
This is just to explain where it all comes from.
Oh, that's stupid. A particle is projected from ground level with initial velocity and angle. Okay. So, ground level, particle, initial velocity is 10. Angle is 20. Oh, no, yeah, 20. And it goes like that. And it comes back down to the ground, I'm guessing. And that's A, that's 20. So we have 20 cos 10, and we have 20 sine 10, and y would equal 20 sine. Oh no, other way round. Why didn't you stop me?
Because I'm such a good teacher.
10 cos 20. 10 sine 20, y would equal 10 sine 20 t minus 4.9 t squared. Find the time of flight of the projectile. I always forget how we do this. So, yeah. What was 10 sine 20? So 10 sine, so t is either going to equal 0, classic, or t is going to equal um 10 sine 20 over 4.9. Oh, that doesn't look like a nice number. I got 0.6 like 98. Might do it the other way. Hang on. Minus 4.9, 10 sine 20. Yeah, I got 0.698.
0.698.
Oh, you did 9.82. I didn't do that one. What was the question? Time of flight?
Yeah.
I didn't do that equation.
Hang on. No. I did something else, sorry. I did something else. So you want the time of flight. Okay, so you would have to do it the other way.
What's the answer?
So I think the time of the flight, my guess is that it's double of what I got. So that times 2. So my guess is that it's 1.86. No, you're right. 0.698. Oh, listen to me. I just
Okay.
did it. I just did it wrong. Okay, B.
And then range would equal 10 cos 20 times that time that I just worked out, which equals 6.56, so 6.6, I don't know.
So 6.6 meters for its range. 6.56.
Yeah.
And maximum height.
Oh, we just forgot how we did it. So what did we do? We did 10 sine 20 t minus, did we do that?
I don't think we found the time of when it's at the maximum.
Minus 4.9 t squared.
Keep in mind that we did find the time of the flight in part A.
Yeah, and then you just substitute t in for 0.349. Is that what we do?
And what do you get?
Wait, hang on. So 10 sine 20 times 0.34 minus 4.9, 0.349 squared, like 0.596825.
Yep.
Yeah, that 0.597.
Yes. Okay. Any questions there?
No.
Okay. Let's do that like that. Okay. Seems like you like the questions more now.
The question one. What? I can't hear.
You said you hated these questions. Now you like
No,
them
I've got my book right now. Now I know what I'm doing.
Okay.
A hockey ball is hit from ground level with initial speed. For how long is the ball more than 2 meters above the ground? Oh, it's just got hard. So,
Good.
got the particle going up at 12, angle 40, up, and then it comes back down. We will know when it's at 2, so we have why don't you have to just work out everything and find out when it's 2?
Yep. When what is 2?
When y equals 2.
Yes, and the way you would say that is resolving vertically, s equals 2.
Okay, so we have y equals 12 sine 40 t minus 4.9 t squared. We need to find out what t is. So t either equals either equals 0 or t equals 12 sine 40 divided by 4.9, which is 1.574, 1.57. What else do I need to work out? So that's time of flight. What else do I need to work out? I mean, the range. I could probably. Do I really need to work out the range? I'll work it out anyway. Because it takes 2 seconds. That's the range. 14.4. Gonna leave it at that. Okay, so maximum height. So we do 2 equals 12 sine 40 t minus 4.9 t squared. Then we do that, then we do minus the 2. Yeah. Actually, I'm just going to put everything to the side. So we get 4.9 t squared minus 12 sine 40 t plus 2 equals 0. And then is t 1.57 or is t half of 1.57?
You're trying to find t, aren't you?
Am I?
You are trying to find. So what you found before, you found at the bottom t is 0, and then here t was 1.57.
Oh, okay.
You now need to find when the difference between the t is when s is 2.
Okay. I just got 2 negative answers.
What's the difference between the 2 negative answers?
The difference between them, minus 1.2468 minus 0.327 equals minus 0.9198. That doesn't sound right. I'm going to add them instead and see what I get. Minus 1.57. Oh! 1.57.
So, no. So I don't know what equations you used or values. So you need to find the time difference between here and here.
Yeah.
So how do you go about that?
Do you just add 2 to something?
Well,
I did s equals 2.
s
So
is 2.
I did literally just what you got right there. 4.9 t squared minus 12 sine 40 plus 2.
What equation did you use?
Equation for what?
So like s equals ut plus a half t squared, s equals
I
vt
did s equals ut
plus a half t squared,
a,
t squared.
yeah.
Equals a half a squared. Okay. What is s?
2.
What is u?
12 sine 40.
U is 12 sine 40 down here when t is
Yeah.
0. Because we have negative acceleration, it's going to be slower here.
So what's u?
U will be v when in between those two.
So what's u?
Well, we need some kind of formula to connect these. So that could be u, which we have. That could be v. We could a is always minus 0, always minus 9.8. What are the other two things we can find? S and S is 2. Yeah. So if we resolve vertically between those two, so S is 2, U is so we're resolving vertically. Hold on. What way are we doing this? Do we start with S as 0 or S as 2? No. We were trying to find time, I think. Yeah. S is 2. U is 12 sine 40. No, we were trying to find V, weren't we? Hello? Are you there? Hello? Hello, hello, hello.
Oh no, obviously not.
Don't need to.
We haven't got V either.
And V is what we're trying to get. So S is 2, U is initial velocity, V is what we're trying to get, and A is minus 9.8. So what
So
can we
get
do?
out here. Which one? V squared equals U squared plus 2AS. So V squared.
Hold on, is it minus 2AS?
I don't know. You're the teacher.
I think it's
Is
minus.
it? Are you sure?
No?
Well, it's going to be a minus anyway because A. Nah, it's definitely a plus. Hang on, I've got my. Nah.
Go on.
You searching it?
Yeah,
got.
I'm sure I have it here somewhere. There they are.
It's definitely. Oh, you passed it. Yeah, I told you. Lol.
Testing it.
12 sine 40 squared plus 2 times 9 minus 9.8 times 2 again. Lol. So 12 sine 40 squared is 59.497. You can just leave that as whatever it is. Plus 2 times minus 9.8 is minus 39.2. So 59.497 plus minus 39.2 equals 20.297, then square root that and you get V. I would never have got this in the wrong thing. I got 4.5.
So if I square rooted this,
I did not get that. You know what S is?
so 12 sine 40 squared
2 times.
minus 9.8 times 2.
Yeah.
So yeah, you don't get anything extra for doing them all separately. So then square root of that. So V equals.
I didn't get that. I'm doing something wrong. Let me try it all in one. 12 sine 40 squared plus 2 times minus 9.8 2. I keep getting 20.29. Which gives, but then when you square root that, I get like 4.5.
So then we're saying that the V of that is either 6.8 or 4.9. Do I see it here?
I have it. What? 7.7.
I've just done it a different way.
Why do 7.7134? Sine 40.
12 sine 40.
Different the same way that we did originally. That's literally what we did before.
Right. Ah, you silly. So did you just do something wrong in your calculator and we got it right the very first time?
Never go back onto the answer. What do they do afterwards? Lol,
They-
that's classic me.
They just found the difference between them.
Oh,
You. So yeah.
that's right then.
So that was right. It's just you just something in your calculator that you're not doing. Maybe you're missing. You might be missing a bracket or something.
Divided by 2, 4.9 is 1.57.
All right.
And then, wait, no, I'm not getting 0.33 or 1.25.
So they saw.
Oh, soz, haha. Wait, hang on, let me do it again. Polynomials, we have 4.9 minus that,
Are you in radians?
Okay. Solve. Oh yeah, I am getting 1.25 and 0.33. But they're in negative. But they're negative though. You can't see. They're negative.
I can see it. Okay, but the absolute difference between them will be, yeah, still the same thing, 0.92. Because you'd get like minus 0.33 minus 1.25. You'd end up with minus 0.33 plus 1.25, which is the same as 1.25 minus 0.33. Okay. And then this is working backwards. Let me just take a quick look. Yeah, let's try to do this.
It's the same thing, but then add 1.6. Oh no, it's not. It's find the angle of projection. Ball is kicked from ground level. When it is at its maximum height, it just passes over a fence 1.6 meters high. Ground level. Speed 20. Dun 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 dun, like that. Maximum height is 1.6. And the angle we don't know, so we can make that x. So we have x, we have 20 cos x and 20 sin x, and then maximum height means that when t is half of t will give us maximum height. Also y equals 1.6. So 1.6 equals. Oh no, it's just gonna have like simultaneous equations in it.
Right.
I don't want to do that. Because 20 sine x t minus 4.9 t squared equals 1.6.
Let's see. What would happen if you did s equals vt?
Oh no, s is horizontal, isn't it?
Yeah.
I haven't worked out. Oh, you can't work out.
So going that way, it's s equals v is the initial horizontal velocity. What would that be?
Oh, what would that be? V is what?
Horizontal component of the initial velocity?
20 cos x
Yeah.
times.
So there you go. So there's one equation that has two unknowns in it.
Yeah.
So there's nothing crazy about that. There's nothing squared or whatever.
Getting the other one.
Maybe I'll call it 20t cos x. Okay.
That's still scary.
Who knows? Okay, let's resolve vertically. So u
20 sine x.
that's 20 sine x. What do we could take here. So at the maximum, what is v?
1.6. Oh.
You do.
V is
So-
V.
No.
0.
V is 0. And what do you... So those are... Let's see. And is there anything else we know? Yeah, there is.
Acceleration. Minus 9.8. And then 2 we don't... Well, 2 technically we could find out, but not really because it's just whatever the half of whatever it is, but we don't know what it is.
Hold the phone. What 4 things... What equation connects those 4?
V, A, U, and S. E squared equals U squared plus 2AS. But that's 20 sine X in it, so how are we going to do that?
You want to solve x, don't you?
No, we've also need to find V as well. Oh, V is 0. Okay.
Like x is literally what we're trying to find, isn't it?
Oh yeah, lol. So yeah, but then so we okay. 20 sine X squared plus 2 times 5 7.8.
Solve time.
So 20 sine X squared plus 2 times minus 9.8, 1.6 is minus 31.36. So make 400 sine squared x equal 31.36. Divide it by 400.
Mm-hmm.
Square root it. And then do sine minus 1 of that answer. Gives you 16.3.
16.3. And would we need to repeat it or anything? 16, roughly 16 degrees to the nearest degree. Yeah, so it wasn't simultaneous equations after all. Resolve vertically. U is 20 sine x, S is 1.6, V is 0 at the maximum, A is minus 9.8. Any questions there?
V 0 at maximum. It's all fun and games, but I swear I would never do this in the exam.
So all you have to do is find 4 things for it. So we found U, S, V, and A. And one unknown is involved, and then we just sub them all into one of the equations and solve it. It's always the same thing. Yes, how was that for you, Saba? So we got done really what I wanted to get done. And yeah. So that's majority of projectiles. There's a little extra stuff, but yeah. Anything in particular you want to do next time?
Whatever there else there is of projectiles, and then you can choose.
Projectiles, fine. I'm